replace the double angle. So here's the double angle. If you look on the other sheet, it says that cos of 2 theta, you have a few options actually. So it says cos 2 theta is equal to cos squared theta minus sine squared. It equals 1 minus 2 sine squared. And it equals 2 cos squared theta minus 1. Okay, so we can replace with any of these. I'm going to replace with 2 cos squared minus 1. And if we get stuck, we could try replacing with another. So I have 1 plus 2 cos squared theta minus 1 over cotan, we know is cos over sine. So I'll write over here cos theta over sine theta. The 1 and the minus 1 cancel. So part of me saw this 1, and then I said, okay, I can make it disappear. Not with the second line, because if I have that one as replacement, I would get 2, and the 1 wouldn't cancel. But if you look at this bottom one, 1 and the minus 1 would cancel. So the numerator can't simplify any further. So in the numerator, we have 2 cos squared theta divided by our denominator, cos theta over sine theta. We change division to multiplication, flip our fraction on the right. We'll see if anything cancels. So we can divide out a cos in the numerator and denominator, right? Because it's cos times cos. So we're left with 1 cos on top and on bottom. So we have 2 cos theta times sine of theta. And if we go back to look at our identities, 2 cos theta sine theta is the same as sine 2 theta. Right? 2 sine theta times cos theta. These are the same, and that equals sine 2 theta. Let's look at the next one. Okay. So for this next one, it says solve for x in this interval, right? We need to replace sine 2x. We're going to go to our identities, right? Our double angle identities. And it says that sine of 2 theta is 2 sine theta or sine x times cos theta or cos x, right? Plus we had a sine x equals 0. Okay, after we do that, we need to look at both terms, right? 1 term, 2 terms. See if there's anything that they both have in common that we can factor out. We can factor out a sine. So we have sine x times 2 cos x plus 1 equals 0. Now we're going to set both factors equal to 0 and solve. So if we set sine x equal to 0, we'll come over here and we set 2 cos x plus 1 equal to 0. We're going to solve both. So the one down here, sine x equals 0, is saying if we spin around the unit circle one time, right, between 0 and 360, where will sine be 0? So let's see, 1, 0, 0, 1, negative 1, 0, 0, negative 1. When we spin around the unit circle, sine is 0 at 0 degrees. So x is 0 degrees. And at 180 degrees. If we come over here on the right, we need to subtract 1 from both sides. So we have 2 cos x equals negative 1. We divide both sides by 2, so we have negative 1/2. When we spin around the unit circle, where is cosine negative 1/2? We see that the cosine is negative 1/2 at 120 degrees and at 240 degrees. So we have 4 values, 0, 180, 120, and 240. Last one for this page. So this one says cos 2x equals sine x. We know we want to replace cos 2x or cos 2 theta with one of our identities, right? The cos one, you have to be careful, right? There's a few options. So we would have cos squared x minus sine squared x is an option. 1 minus 2 sine squared x. And 2 cos squared x minus 1. So we have three options for cos 2x. If we're trying to solve, right, we first would want to get everything on one side. So if we move the sign to the left and we need to replace cos 2x, we want to decide what we should replace cos 2x with. So if I'm keeping sine x and I want to replace cos 2x with something, I'm going to want to find something with sine in it. So I'm not going to use the last one because that's 2 cos minus 1. I'm going to use the center one because that only has sine. So I'm going to replace cos 2x with 1 minus 2 sine squared x minus sine x equals 0. I see a quadratic, so let's try to factor this. So we have negative 2 sine squared x minus sine x and 1 equals 0. I'm going to divide out a negative 1, so I'd have 2 sine squared x plus sine x minus 1 equals 0. Now let's try to factor. 2x squared plus x minus 1. What two numbers multiply to negative 2 that add to 1? Let's see, it's some combo of 1 and 2. So if they add to positive 1, the 1 needs to be negative. Negative 1 times 2 is negative 2, and negative 1 plus 2 is 1. So we can group. We'll have 2x squared. We'll replace the center with negative 1x and 2x minus 1. The left pair have an x in common, so we'll have 2x minus 1. For factoring by grouping, parentheses need to be the same, so I know in front of the other parentheses set it's a 1. We can keep bringing that negative 1 out and down. So then we'll have negative 1's on the outside. We'd have x plus 1 times 2x minus 1 equals 0, and now I'm going to throw a sign back in there. So we have negative 1 times sine of x plus 1 times 2 sine of x minus 1 equals 0. You then set each factor equal to 0 and solve. Well, if we set negative 1 equal to 0, that doesn't give us anything. So if we set sine x plus 1 equal to 0, sine x equals negative 1. So when we spin around the unit circle, where is sine negative 1? Well, it's negative 1 at 270 degrees. And over here, if we set 2 sine x minus 1 equal to 0, if we add 1, we have 2 sine x equals 1. If we divide by 2, we have sine x equals a half. So when we spin around the unit circle, where is sine a half? And it's a half at 30 degrees and at 150 degrees. And that's it for page 8.